Welcome to Intersect Feed Management Integrated Overview presentation. So in this presentation, I will be focusing on why and later on how to move beyond the standalone reservoir simulation towards actually simulating true integrated asset modeling. But in this particular presentation, the focus is on why. So I'm going to discuss why the reservoir forecast often represents nothing but the theoretical production potential and the actual field performance. The actual field performance is a function of many other factors. It's typically influenced by the well constraints, the facility limitations, the network back pressure, and the operational decisions. So using Intersect Feed Management, we will be able to couple multiple reservoirs together, as well as integrate the network with the reservoir. And that will give us the platform to be able to capture the interactions in a more realistic way and understand the true value of an asset. So this will enable better production allocation as needed, and more effective facility utilization, and also better field development decisions. Here is the agenda for the presentation. So we're going to, in this current video or recording, I will focus on the introduction to integrated reservoir network modeling. The next video will be on reservoir coupling. That gives us the flexibility to couple multiple reservoirs together. Then we're going to look at coupling the reservoirs with the network. And we'll look at different types of the network simulators that are supported by Intersect. Before I dive into that, why, let's look at some of the challenges that we have with field development life cycle today. We've seen significant value loss, which commonly occur across practically all the field development life cycles. According to industry data, based on the source, the multiple industry survey, it was highlighted that 99% of the projects failed to reach their forecasted peak production, the offshore projects, which immediately would tell us that the uncertainty management are part of the major issues that we are facing here. In the same publication, about 42% of the fields experienced major operational issues starting from the first year, which are due to maybe design assumptions that did not fully cover or account for the reservoir complexities and the system integrations that exist. Another challenge is around the cost performance, which is a major concern in our industry today. And around 40% of the projects, according to this publication, overrun both schedule and the budgets, leading to an estimated average 30 billion per year in value lost globally, associated with the project overruns alone. So what we've seen basically on this slide is the fact that so much value is lost between the field expected performance and the actual performance that we've seen before. In the green bar, we can see the potential value, but the true value at the end of the day represented by the orange bar. So some of that loss, they come from the reservoir issues. And of course, some of them are associated with maybe the well restrictions now are imposed, and also the network bottlenecks. And the biggest source of this value loss lies in what we call the integration loss. Take, for instance, a reservoir engineer may predict a certain production rate from a well, but once that well is connected to the shared production system, the facility constraints are imposed, the back pressure from the network, they impose to the reservoir side to the well, causing maybe virtual choking effects or something because the facility cannot support that level of production, then that will automatically reduce the achievable rates. So one thing that we need to bear in mind is a well does not operate in isolation. Production from one reservoir can directly impact the performance of wells in another reservoir when they share the same gathering system or the same facilities. And this is where integrated reservoir and network modeling becomes important. By simultaneously considering reservoirs, the wells, the surface networks, looking at the whole system holistically, it will help us to really understand the true potential of the asset and make better field decisions. So I'm going to just focus on some of the challenges. Some of them I already highlighted them, but just to expatiate more on them. And the first issue is the lack of integration. A lack of integration. Reservoir, wells, facilities, network team, or in reality, those entities, they are not in silos. So modeling them should not be done in silos as well. Because the reality is the asset is producing in an integrated manner. And as we've seen on the right-hand side, this leads to sequential losses, such that all the way from we're down to this point. Reservoir issues, well restrictions, creating bottlenecks, the network bottlenecks. I think that is important to think about the system and model the system as such, as an integrated model. Number two is the limited collaboration among the teams, the disciplines that are involved. We need to remember that each hands off between disciplines introduces inefficiency into the modeling outcome, and it erodes the value. And it is something we need to really consider, because each team can optimize their own model individually, but without a system level view, these local optimizations will not translate into the maximum field value. Another factor that we need to bear in mind is the absence of automation in most of the workflows. This is changing, by the way, with the digital coming into the picture as enabler for automation in the industry. But many workflows still rely on the manual data transfers, sharing spreadsheets, and the rest. And this makes scenario evaluation slow, and it limits the ability to respond to changing conditions. And lastly, I would like to touch on the lack of actionable insight, in spite of the fact that the industry has very large volume of data. But most of them are not converted into timely and decision-ready information. So we really need to, when we're working on field development projects, we need to have this in mind and minimize the impacts so as to ensure that we are not eroding some of the value that we propose in the projects. In this slide, I'm going to focus on the technical challenges. And there are many technical challenges, from flow assurance, the design optimization, the rates that can impact our model at any point in time. And that is why modeling the entire assets as a single unit, all the components simultaneously together, helps to really factor some of these challenges into the overall outcome that we expect. At the reservoir engineering level, we often work with multiple reservoirs, multiple compartments, accumulations, as we can see here, this reservoir, all those accumulations. Each with its own history match model, local optimization, which is fantastic. However, the key point is reservoirs, and I will repeat, they do not operate in isolation in real life. They won't just produce into the space. You need to tie them up with the production facilities, which will impose the back pressure on those wells and change what they are able to deliver. So all this will need to go together. Those boundary conditions that we usually specify as a constant value, that is far from the reality. In many assets that we work with, especially in the offshore development, all the reservoirs ultimately flow into the same production network. They share the same subsea system. They are constrained by a single platform, the risers, the topside with the fixed capacity limit. And this is where the standalone optimization breaks down. No, we can't do that. We can't work in silos. You can have perfectly optimized individual models, but everything, once you connect them together and you introduce the shared constraints on them, whether it's a platform capacity, whether it's a facility handling limits that you need to impose, water injection availability, whatever it may be, then they all have to respond together to that. So what Intercept enables us to do is to move from the local optimization to a system level optimizations. So we're able to couple the multiple reservoirs together with the wells, with the network, so that decisions are made holistically. And this allows us to really answer the right questions. Which reservoir should produce when? If we don't tie them together, we model everything to produce at the own time. How should we allocate the capacity? What is the real field level optimization under the constraints that we have? It is the true value is only delivered when all of them are connected together as an integrated system. So this slide illustrates the versatility of Intercept FM. Intercept FM as an asset level control and optimization tool. FM extends beyond the traditional reservoir simulation. It provides the capabilities across the 4 pillars that I have on the slide. The first one is the control and the optimization, where we can implement operational constraints, intelligent completions, as we can see, and all form of optimizations, because Intercept itself has inbuilt optimization tools that they help you to really automate and optimize your production. The second one is the resource management, where you are able to mimic the field operation more realistically. Think about it. If you have any limited resources, your model may not be aware of such if you don't factor them into it. If you intend to drill 30 wells, for instance, or at the end of the day, you only have 2 rigs, the 30 wells cannot come on stream about the same time. You have to drill the first 2 before the rig can be available to drill the last well. This is the reality of the operations. And as such, you need to factor them into your modeling. It could also be budget. It could be the amount of the chemicals that are available. So you can make your model to be aware of these resources, the quantity that are available, when they will be available, and it's able to incorporate that into your field development logic. By design, we can also integrate multiple reservoirs together, couple them with the network, so this facility is available. And finally, and this is what actually differentiates Intercept from many other simulators out there, the ability to extend the capabilities of Intercept through the connection with the CSV controller, such as a spreadsheet-like file, and you can read the data directly from there into the Intercept. You also can connect Intercept with third-party package, such as Python, for advanced automation workflows. And this is what really sets Intercept apart when you look at it. And this slide illustrates the architecture of Intercept FM, how it provides a flexible framework for the asset level control logic that I've discussed. And at the core is the strategy, which defines the operation objectives that you have, determines which actions are executed. So you have different actions being triggered in your instructions that if production goes beyond this, maybe drill a well, perform this task, do whatever that you want to do. So you can set up your instructions with your actions, and once they are triggered, they help you to be able to model your field strategy development in a more realistic way. You have things like the inputs, like the flexible expressions that you can use. The strategy can use inputs like control, the dynamic list, and so on and so forth. I mentioned the resource management, the option that you can also incorporate into your strategy. So looking at all this together, they actually provide the building blocks for our FM strategy. You can impose constraints from the network or from the facility. The allocation, you can allocate them as needed. So while this presentation provides just an overview of the importance of integrated approach to reservoir and subsurface network modeling, I'm going to give a short overview of how to couple the reservoir together in the coming recordings, in the future recordings. I'm going to also show how to couple the reservoir with the network facilities. However, for the deeper understanding of these concepts, I would recommend that you sign up for integrated field management workflows in Intercept. We have the reservoir coupling one that focuses on the cross-reservoir balancing, the coupling of multiple reservoirs together. And we also have the network coupling that helps you to couple the reservoir with the surface facilities. So together, I believe that these two courses will provide the detailed knowledge that you require to build and manage and optimize fully integrated subsurface to surface simulation workflows. Thank you and see you in the next presentation.